All right, we'll go ahead and get started. Welcome, everybody. Thank you for joining our Tabular webinar today. I am Jason Reid. I'm one of the co-founders here at Tabular, and I also lead product on a day-to-day basis. Prior to Tabular, like my co-founders, Dan Weeks and Ryan Blue, I spent 8 years at Netflix where we wrote the original Apache Iceberg implementation, and obviously put that to good use for Netflix's data practices there. And today, I'm going to be going through Tabular's product and how it addresses the 7 best practices for a successful Iceberg implementation. So if you happen to join us last month, my co-founder, Dan Weeks, gave a webinar. It was very just open source focused on what do you need to do to be successful with Iceberg in your organization. And that was very much an open source focused talk. Today, unabashedly, this is going to be very Tabular focused. So Tabular specifically, how do we opinionated solve these best practices, and why do we think Tabular is something you should consider adopting within your organization if you are wanting to take advantage of Iceberg to its fullest extent. So without further ado, I'm going to get started here. Yeah, how Tabular implements the 7 best practices for Iceberg. So these are the 7 that Dan Weeks covered a month ago. And I'm going to go through each one of these, and obviously Tabular as a product has an opinion about all these best practices, and they're all baked in to the platform, as you can imagine, right? You can think of Tabular as what we wanted to build after having done, baking in most of these best practices to what we had built at Netflix, but getting a chance to do that all over again from scratch with a V2 of an Iceberg implementation, also unencumbered by the constraints that a place like Netflix put on what we could build. And here Tabular is sort of just the very best version of all of these things and all of our lessons learned baked into the platform. So go through these and hopefully leave time at the end for Q&A. Oh, I gotta share the screen. Thank you for somebody helping me out on that. Let me come back to where's my room. All right. Hopefully we got our screen up now. So we're covering the best practices and for each one, like how Tabular thinks about implementing these things. So first, I just want to give a high level sort of level set everybody with a picture of Tabular. What is the Tabular platform? How does it integrate with Iceberg and all of your own infrastructure if you're thinking about using Iceberg in your world? So Tabular is first and foremost a REST catalog. We'll talk more about that. It implements the Iceberg open source REST catalog protocol, and it's a SaaS product. So it's all serverless. We handle all the infrastructure. There's nothing for you to run in terms of infrastructure to take advantage of Iceberg with Tabular. The other really important pieces that are called out here that obviously Tabular are a table optimizer. We'll talk more about that, but it handles all the table maintenance operations as well as a lot of the more advanced optimization techniques in Iceberg, and automated systems for ingesting or for getting data into your Iceberg tables, things like data loader and change data capture and such. So that's the stuff that runs on the Tabular side. If you're using Tabular, one of the nice things is you keep 100% open source Iceberg tables in your own infrastructure, in your own cloud storage. That can be on S3 or Google or Azure. Keep those tables in your storage. Use whatever compute engines you want. Tabular is unopinionated about the style of compute that you want. We want you to use many have flexibility, have options in terms of the compute engines you're going to use with your Iceberg tables. So that can be open source engines like Spark and Trino, Flink, but also vendor computes like Snowflake and Athena and BigQuery. So the first thing that Dan talked about was if you're using Iceberg, you got to select a catalog. So a catalog is an important part of your Iceberg infrastructure. Like any data warehouse system, it's the piece that helps engines actually address the Iceberg tables, find out where they are in your underlying object store, figure out what the schema is, and also handling things like transactions and commit protocols, making sure we get our asset semantics for our Iceberg tables. So that's an important piece. Dan's recommendation last time was, hey, REST catalog, REST is best. This is, again, a open source specification in the Iceberg project, and it just has a bunch of endpoints. It's an open API specification that says, here is how engines and other tools and systems should interact with Iceberg tables. How do I append data? How do I update data? How do I read data? All those pieces flow through the catalog. And having that REST protocol has a lot of advantages. And so, not surprisingly, Tabular implements that REST catalog specification. Now, the Apache Iceberg project is first and foremost a specification. It's different than other Apache projects, which may have actual systems that you run. You don't download Iceberg and run it. That's not a thing. Iceberg is a table specification. It's meant to standardize the way that query engines interact with tables on object stores, right? There's a lot of power in that abstraction. Having a standard, instead of having all that information locked within a single data warehouse and a bunch of proprietary formats, proprietary storage, what Iceberg allows us to do is really have shared storage, a singular storage model that multiple different compute engines can interact with. That's the power of the Apache Iceberg table specification. But there isn't a runtime that comes along with that. And so when you think about using Iceberg in your organization, it means you need a catalog, and it means a bunch of other runtime pieces, which we'll talk more in detail about that are part of the Tabular platform. But it comes with the REST catalog. It's obviously unlike the transitional catalogs that Dan talked about last month, say like a Hive Metastore, which is really not designed for Iceberg. The Tabular REST catalog is designed from the ground up to be high performance and high availability Iceberg catalog. It supports multi-cloud architectures. So within the same Tabular environment, you can have tables stored in GCS as well as tables stored in S3. You can query those tables together. You can join them from Spark if you want. So it really unlocks a true multi-cloud architecture, which has a lot of benefits. It's got a unified catalog and data governance model. What I mean by that is when we think about security and access controls in Tabular, it's cohesive in the sense that you have access controls that govern things you can do at the catalog layer, creating databases, creating tables, renaming tables, dropping tables, all of those types of things, as well as data activities. So reading and writing data within a table, things that are happening in the object store. In most other systems, those things are separate. You've got you're trying to use like bucket policy to control access to your files, and some other policy to control access at the catalog layer. So if you're doing things with Ranger or Glue, IAM permissions, it can be quite convoluted and complicated. And with Tabular's catalog, you get a single sort of catalog and governance model. So you set up your roles, you define which access those roles have, and that covers both catalog operations as well as actual data read and write. One of the big benefits of the REST catalog versus other catalogs, and Dan mentioned this last time as well, is the ability to do commit deconfliction. Because of the commit protocol in the REST catalog, you have a little bit more degrees of freedom in thinking about how if you've got multiple different updates that are trying to happen to the same Iceberg table, you can be more intelligent about how you deconflict those commits. So as an example, in the Tabular platform, we're going to do a lot of maintenance activities for your tables for you behind the scenes. We're going to compact small files. We're going to rewrite metadata, things to keep your tables healthy and performing. But we never want those operations to potentially conflict with user operations on the table. If you're actually, writing new data to the table, that should take precedent over these optimization and janitorial type of workloads. And so our catalog does that intelligent commit deconfliction where we're making sure that our background tasks are staying out of the way of user updates to the table. View support, so this is exciting. Apache Iceberg 1.5, I think, officially launched yesterday. And one of the big features in the 1.5 release from Iceberg is support for Iceberg views. Big step forward for the project and the community. Not surprisingly, the Tabular REST catalog already has support for views as that launches in the Iceberg project. And so, we're always up to date on the latest features in Iceberg. Support for things like Terraform and infrastructure as code. So, if you want to use infrastructure as code tools like Terraform to manage your Iceberg infrastructure, that Tabular has Terraform modules to support that kind of operation. And just a bit future looking here and things that are coming down the pipe. I'll talk about a number of these sort of future looking features in Tabular as we go forward. But one of the big ones is multi-table transactions. So that's something that also is being worked on in the open source community, something that we're excited to get into the REST catalog protocol, which just basically allow for having transactions that span multiple tables. An important part of doing data warehousing and getting transactional consistency. And maybe one of the biggest important takeaways here is because it's the open source REST catalog that you're using with Tabular, there's no lock-in. This isn't a proprietary catalog of any kind. It's easy to get your Iceberg tables into Tabular's REST catalog. It's just easy to get them back out again. You could take your Iceberg tables to any other catalog, and they work just as well. So it's great being open source all the way down the stack, from the catalog all the way through the table format. You're really free to move throughout the cabin as you see fit when it comes to your data. Oh, and maybe the very best part about Tabular's catalog is it's actually completely free to use. So you can sign up for Tabular, you can use the Tabular catalog. We don't charge for usage of the catalog. And so it's a really great option for getting started with Iceberg, or just really having a enterprise grade, high available catalog that's free to use. That's a really powerful construct. And again, you're not locked into it long term, so it's easy to move on if we're not getting value out of Tabular. All right, the next best practice on the list was ingesting data. Important part of using Iceberg is how do I get data into the Iceberg format. Dan's best practice was land data immediately. And what he meant by that mostly was the sooner you can get your data into an Iceberg table with structure and schema, the better. So you don't lose a lot in translation. So you can stream directly into Iceberg tables. You can use something like Spark or other tools to land data in. And obviously at Tabular, we fully support all these mechanisms. In addition, we have some proprietary features in our platform, which our customers find extremely valuable. So a simple one, but a powerful one is File Loader. And this is just a system that monitors S3 locations or any object store location for new files, so that as they land in your object store, our systems will automatically read those files, apply the right Iceberg structure and schema and metadata, and write that data into your Iceberg tables. It handles any volume of files that you can throw at it. It handles automated schema evolution. That's a really powerful one that you don't have to engineer this stuff anymore. It can get really messy with JSON and things like that. And the cost model is based on gigabytes loaded. So it's a serverless product. You don't have to think about how many clusters you're running, right sizing your clusters. Am I running Spark jobs? Are they running out of memory? Do I need to scale my Spark jobs if I have more files landing? All that operational burden is handled on the Tabular side, and you're just paying for the value you're getting, which is how many gigabytes am I loading into this system. Just a quick picture of how this works. It's relatively straightforward. You've got some area in your object storage, this landing zone. You configure it so that Tabular is receiving notifications when new objects, new files land in those spots. We then batch those notifications up. We run them through our file loader service. It reads those files from S3 and then writes the data out into your Tabular warehouse, right? Handling schema evolution and guaranteeing exactly once delivery of those files. All right. We also support Kafka Connect. So the Tabular engineering team originally authored, open source, and is now contributing to the Apache Iceberg project, the Kafka Connect system. Really nice way to get streaming data into your Iceberg tables. It handles exactly one semantics. It handles schema evolution. commit coordination. Dan talked at length about the power of this Kafka Connect system. And it's really this simple. Like, it's just a matter of a handful of configuration. You deploy this into a Kafka Connect environment, and now you've got your streaming data automatically landing into your Tabular Iceberg tables. So here you can see we are providing the Iceberg sync connector. We're saying this is a REST catalog type. This is going back to the fact that Tabular's catalog is just an open source Iceberg REST catalog. You point at the Tabular endpoints. You provide authentication through a credential, and you tell it which warehouse you want these tables to be created on the Tabular side. And then a few other really nice properties for auto creating tables, evolving schemas, being able to fan out, so you can have a single Kafka stream that fans out to multiple target Iceberg tables. You can also control how frequently those things are committed. So, you could every 30 seconds be landing data into your Iceberg tables. So very near real time capabilities coming straight from your stream into Iceberg tables. If you're not using Tabular, this all still works. So this is open source, but there's some things that you're going to have to consider in terms of sizing these clusters and thinking about how do you do maintenance on those tables over time. If you're committing every 30 seconds, you're going to have a lot of small files. You have a lot of metadata building up. Tabular's platform is going to handle all that for you. In addition, in next quarter, we're going to be launching a serverless stream ingest product. So basically, we'll run the infrastructure, just point it at your Kafka streams, and we'll take care of scaling and managing, getting all that data into your Iceberg tables. You can also use any of the open source tools. So Spark Streaming, Flink, all that stuff works for getting your data into Tabular, because again, they're just open source Iceberg tables. The next best practice here is about connecting compute environments to your Iceberg tables. And the best practice was a focus on flexibility, right? One of the key value propositions of using Iceberg is the ability to use multiple different compute systems on top of the same exact data sets, right? For different use cases. You want to use Spark for your transformation workloads. Maybe you want to use Trino for your analytics, or a number of other tools, whether it's Python, things like DuckDB or Polars. All this stuff can work on top of your same Iceberg tables. And not surprisingly, Tabular leans heavily into this. We are a storage-only platform, meaning it's a bring your own compute. We want you to bring any number of different compute environments. We're not going to push you into using a particular style of compute. Our system is designed to work well across all the compute engines that support Iceberg tables. So we have, this is actually a screenshot from our product. When you go into the Tabular product, we have wizards that walk you through connecting your Tabular warehouse to all these different compute engines. So various offerings from AWS, like Athena, EMR, open source tools, Spark Trino, other vendor tools like Starburst, Stellar Data, which is a StarRock's vendor, even Databricks works great on top of Tabular tables from their Spark runtime. We also support read-only from these engines, which these don't have write-back support to Tabular's REST catalog yet. Is hopefully work in progress, but you can synchronize and do read-only queries from Redshift, from BigQuery, from Snowflake. So really leaning into the optionality. You can use all the Python tooling as well. You've got a lot of options when it comes to how you want to, which compute engines you want to connect to your Tabular warehouses. All right, the next best practice, and I actually combined two. There was two here that Dan mentioned. For the purposes of Tabular, I'm going to talk about these two things together, because in Tabular's world, we think about these two functions in unity. So maintaining tables and optimizing performance. And the best practice for maintaining tables was, hey, aggressively maintain your tables, right? At Tabular, we take a slightly different stance on this, which is intelligently optimize your tables, right? So aggressively maintain, in a lot of cases for people using open source, is, well, I'm going to set up a cron job every hour to go and compact all my tables. Or at the end of every ETL job, I'm going to run a compaction or a metadata rewrite or whatever it is that I need to perform maintenance on my Iceberg tables. And that's okay, but it turns out we can actually do a lot better than that if we bring some intelligence into our maintenance services. And so in Tabular's land, we connect the catalog activity with our maintenance services so that on every commit to a table, every change to a table, we are inspecting that set of changes. We are looking at historical performance of a table, and we're deciding when is a good time to run maintenance activities. So A, that they stay out of the way, and B, that we're maximizing the value of actually doing that maintenance. Are we going to be able to compact a lot of small files? Are there more files likely to come into this partition in the next 5 minutes? Maybe we should wait, things of that nature. The other best practice around optimization was enhancing your data engineering practices with Iceberg features. So those are things like using hidden partitioning, et cetera. At Tabular, we would say, hey, the Tabular platform has got all that baked in. We already leverage all the Iceberg features to optimize the physical layout of your tables. And that just allows your data engineering team and the rest of your data users to focus on business value. These are very low-level things that honestly platforms really should be doing. And we don't need data engineers to spend a lot of time thinking about, are they optimizing the right partitioning scheme? Are they sorting on the right things? Are they clustering on the right keys? Again, we can leverage the catalog to look at read and write patterns for tables and automatically choose the best physical layout for your Iceberg table that's going to minimize the cost as well as maximize the query performance. I'll talk more about that coming up. Okay, well, so when we talk about intelligent maintenance, intelligent optimization, what are some of the key things? So snapshot expiration, this is the act of removing old history from your Iceberg tables. We do that automatically at Tabular. You don't even really think about it. There's take the defaults are mostly good. You also have configuration about if you want to keep longer history or shorter history. We can do that automatically for you. Orphan file cleanup. This is hey, sometimes you have jobs that run that maybe don't actually commit data. They've written data to disk, but don't ever commit it to the table. So you have these orphan files that are left around. We handle cleaning all those up in a very optimal way. And things like rewriting metadata. So, if you're, again, streaming a lot of data into a table, you're going to build up a lot of metadata over time. And oftentimes that metadata isn't aligned with your query patterns. And so we want to take your Iceberg metadata, rewrite it in such a way that it aligns with your query patterns so that when engines are running queries against your table, we're getting the maximum value out of Iceberg's indexing and file pruning capabilities. And again, we're looking at those query patterns against your tables so that we can make sure to line that metadata up with your query patterns. All this is fully automated. It's kind of set and forget stuff. You don't worry about it if you're using Tabular's platform. In addition, all those data engineering activities, these are things that even at Netflix, we had a lot of data engineers who spent a lot of time focused on trying to solve these problems. And I'm really happy to say that the Tabular platform handles all this stuff automatically, and it does it in a very intelligent way. So obviously compacting small files, we're all very familiar with the small files problem and why we have to compact those things in large tables. Again, we do that very intelligently, deciding when to compact files, how many files to compact at a time. If you've tried to do this yourself in other engines, there are a lot of challenges with doing it at scale. You got tens or hundreds of thousands of jobs. You have to contend with memory challenges and commit contention. And we're handling all that behind the scenes in Tabular. Taking advantage of partitioning, sorting, all that stuff is handled by Tabular's optimizer. Again, we are able to see the scans that happen against your Iceberg tables when queries are being run. We know which predicates are being used across different queries, and we can really auto cluster and line up the physical layout of your Iceberg table to maximize the performance of those queries, as well as reduce the size of your data on disk. Even choosing the right compression codecs, which I don't mention here, is something that we do automatically. So, should it be Z standard? Should it be gzip? Should it be snappy? And the reality is it depends. Every data set is different. Every data set responds differently to different compression codecs. And our system is smart enough to choose the best one on a table by table basis. All right. Next best practice was all about security. And really the answer is here is like, yeah, you should secure your data. It's a valuable asset in your company. If you've just got Parquet files in S3 and you've got wide open bucket policies because your data scientists need to run Spark jobs and there's no other way to secure your data, that's a big risk for your data and for your company. And in Iceberg, in the open source, there's a couple of existing standards. There's OAuth 2 protocols as well as SIGB 4 protocols. These are both supported in the REST catalog. So obviously there's support in Tabular. And that's really just how do we do authentication and identity between a compute engine and a catalog like Tabular. So that's great that we can leverage those open source protocols. It means that there's no special code that has to be run inside Spark or Trino in order to do that identity and authentication handoff between those compute engines and Tabular. But beyond that, the question is, like, what are you going to use to set the actual access control policies? That is left up to implementers. And in Tabular's case, we've got a role-based access control system, right? So this is going to feel very familiar to you if you're coming from any other SQL-based data warehousing world. You can set privileges from the very top level, the warehouse level, all the way down to column level in Tabular. You can use role hierarchies, so you can nest roles and build role hierarchies as you're building up your organization and your groups. You can do things like map IAM roles. This is really, really valuable if you happen to be running an AWS and you've got, let's say, Spark jobs running under a certain IAM role on certain compute clusters, EMR, or even Databricks clusters running on a particular IAM roles. You can map those over into Tabular roles and basically assign permissions that way using the SIGB4 protocol. And if I back up a slide, this is super powerful because you can configure, this is an example from Iceberg, but it works the same from, say, Spark or Trino. You're just going to configure this compute engine to say, hey, I'm going to be using SIGB4 as my authentication mechanism. And here's my Tabular endpoint that represents my catalog. And without having to provide any other credentials or secrets, Amazon on AWS's SIGB4 protocol will handle validating that, yep, this compute is running as the particular IAM role. That IAM role has been mapped to a set of privileges on the Tabular side. And then that compute engine is only going to have access to the data sets that have been governed by your access control policy. So that means no credential management, no secret management, very secure way to give access to compute to just a subset of the data that it needs access to. So if you've got a job you're launching from your scheduler, from Airflow, you can say, hey, this job only needs access to these tables, so it should run as this role, and all that can happen without having to pass any secrets around our credentials. So powerful stuff, powerful patterns you can build here. The ability to synchronize your enterprise roles and members. So if you've got Active Directory groups or things set up in Okta, all that can be synchronized over to Tabular, and then you can use those groups again to define who has access to what. And a comprehensive audit log of all the authorization decisions that the system makes, and which users are accessing which tables, who is responsible for any commits to tables, things of that nature. And as you can imagine, we deliver that audit log as an Iceberg table. So you can use all the tools you can use against Iceberg, you can use to consume and build reporting off that audit log. So really nice for compliance and auditing, SOX and other compliance capabilities. The last best practice that Dan touched on was data privacy and compliance. These are obviously other important things related to security, but I'll dig into them a little bit more. His recommendation was leverage Iceberg features. What does that look like in Tabular? So he talked about using things like tags for preserving historical snapshots. If you need to go back and say, this is the version of the table that I used for my quarterly reporting for SysOps compliance. You can do that. Tabular supports all these Iceberg features: tagging, branching, obviously maintenance, as well as views. So I have views here on Thursday, 3/14. So Pi Day in 2 days with our next production release, since the Iceberg 1.5 release just came out yesterday, Tabular will have full support for Iceberg views. That's exciting. In addition to the standard Iceberg features, Tabular does have some more proprietary features, specifically around governance and compliance. So we have the ability to do column level labeling as well as masking policies for columns. You can do record level retention. So you can set, hey, for this table, I only want to keep data for up to 6 months. And after 6 months, it should be automatically removed. So you can set that up for any given table, and Tabular will automatically purge old records from the table. Data anonymization. So we can, in addition to masking columns, we can actually anonymize columns. So maybe you have emails or customer identifiers that you need to anonymize either immediately or after a period of time. You want to hash them, something like this. You can set those policies up in Tabular and we'll automatically anonymize certain columns over time. And that's doing it physically in the Iceberg table. So anybody reading that data would see only the anonymized information. And in the second half of this year, we're going to be delivering some more dedicated features for helping our customers with GDPR compliance. So these are primarily the right to be forgotten challenge in data warehousing, where you've collected a bunch of information about users, and then for whatever reason, you need to purge all the information about a particular user from your entire warehouse. And so we'll have the ability for our customers to tag certain tables and columns as being involved in GDPR purging, and then give us a set of customer identifiers, and we'll go through the warehouse and automatically clean that stuff up, including any historical snapshots and time travel that need to be cleaned up as well. So with, time travel is great, having history is great, but for GDPR, it could actually be quite challenging because you actually need to purge even the history of that customer. And that can be a challenge, and Tabular is going to be helping our customers tackle those kinds of issues. All right, I'm going to pause here for a moment. I think that's most of my slides. So we've got lots of time for Q&A. So if you have questions, please go ahead and dump them in the Q&A, and I will start to work through them. The first one I have here is, how is Tabular managed Iceberg better than Snowflake or Databricks managed? There's lots of ways to answer that question. Databricks, first of all, doesn't have managed icebergs. That would be sort of a Delta Lake situation. That's a whole different conversation that I will maybe come back to if we have time at the end. In terms of Snowflake's managed iceberg tables, I think the big difference is going to be, because Snowflake is a query engine in itself, it's obviously everything that the Snowflake is doing for the iceberg tables is tuned to work well within the Snowflake compute environment, including their catalog, right? It's not the open source catalog, it's a proprietary catalog. And today they only allow reading for those iceberg tables from Spark. I'm not sure you can, maybe from Trino as well, but you don't have the same optionality around compute that you would with pure open source iceberg tables like Tabular provides. Obviously, Snowflake wants you to run all of your compute in their world. That's how they make money. So it's definitely not as open as, say, using something like Tabular, where it's a bring your own compute model, including Snowflake. You can use Snowflake to read iceberg tables, Tabular managed iceberg tables. The next question is, how is column level security enforced in Iceberg? Won't untrusted compute engines get data at Parquet file granularity that includes all the columns? So the answer to that is yes. If you have untrusted compute, ultimately, we're not involved in directly reading files off the disk, right? Tabular is not directly involved in that process. And so if you've got a compute engine that can go directly against S3, we can't enforce any column level security there. We're not a compute engine. What we do in order to help in this scenario, and it works better in trusted compute environments, say like a Trino, where you don't have direct access to the underlying file system, is we at the catalog layer manipulate the Iceberg metadata so that the compute engine basically doesn't see columns that the user doesn't have access to, and therefore won't and can't read them off disk. But it is that only works in secure compute environments like a Trino, where you don't have access to the underlying file system. You had Spark and you can get it S3. To your point, you can read the Parquet files and the columns will be there. That's where the data anonymization services come in. If you want to physically anonymize the data on disk, we can do that as well. And then it works for all compute engines. Next question I've got here is, how is the RBAC defined in other compute engines to work with RBAC defined in Tabular with accessing Iceberg? Which one is honored? So one of the key architectural decisions when you're working with Iceberg is where should security policy be enforced? And if it's defined in multiple places, how does that all actually work together? Our opinion is that if you want this world where you've got multiple different compute engines interacting with your Iceberg tables, that the best practice is to have as much security as you can on the storage layer of the Iceberg table, right? Because then you're not reliant upon all the different engines to enforce security, which can be difficult to coordinate across engines, and in some cases is impossible to do. If you've got native Python processes trying to read data from your Iceberg tables, like how do you secure that effectively without something like Tabular? I don't think it really exists. And so we would definitely recommend, set your security policy at the storage layer. We can share some links. We have a whole blog series about securing the storage and how that all works in Tabular and how it works across engines. If you happen to have additional security layers in the compute, so as an example is you might want to do dynamic row filtering. Obviously, that's something only the compute engine can do, right? You can't do that at the storage layer, at least not today. There is work going on in the Iceberg project and Iceberg community to have communication of some of these dynamic filtering policies happen between the catalog and the engine. So we'll see how that evolves, and obviously Tabular will be involved in that. But ultimately, you're relying on the compute engine to filter rows out after it reads it off of disk. And that's fine. You can layer those things on top of each other, right? So the reality is like both can be applied. You can apply security at the storage layer, and then you can apply additional more fine-grained security at a compute engine layer in situations where you need it. But it's good to have that base security layer, so you're not just opening up S3 access to Spark or data science Python processes broadly. Next question is, while at Netflix, what were some of the biggest challenges of managing Iceberg implementation? Anything I wish I had done differently? Yeah, I mean, I think the Tabular platform is a lot of the things that we wish we had done differently, right? A lot of those lessons learned are baked into how Tabular operates. For starters, when we were all these data engineering best practices I mentioned about partitioning and clustering and really tuning the physical layout of tables. At Netflix, that wasn't automated. It was very manual. We relied on data engineers to do it, and it's not something new. Like they've been doing this forever, right? Like you saw in Hive tables, you had to do this. So it wasn't new work they were doing in Iceberg. But the reality is, with Iceberg, we could move that work to the platform and automate it, and we never quite got there at Netflix. I actually think they have done some more work to further that initiative internally at Netflix now since we've left. But I'm happy to see that. I think that makes a lot of sense to take that burden off of data engineering. And not just data engineering, you have lots of people in an organization who are creating data sets, who are creating tables, analysts, data scientists. Lots of people create data in your organization, and most of them don't have the expertise that data engineers have to do this optimizations. And so turning it over to the platform, letting the platform really do it, has a lot of advantages. Now everybody can take advantage of Iceberg's features to have those optimizations done. So that's a big one. The other one is, we never really nailed the security story at Netflix. I think they've done some work again since we've left, but I'm really happy with the fact that we decided to bake a really robust RBAC security system into the Tabular platform from day one. It wasn't something we tried to bolt on later. That's very difficult to do. And so we did the work up front to make sure that we had a robust security system in place. All right. Next question here is option D Snowflake to read. Is this based on Tabular writing back table DDL to Snowflake? So to answer that question, yes. So the way that we enable Snowflake to read Tabular managed Iceberg tables today is using Snowflake's external Iceberg, or what do they call it, unmanaged Iceberg table integration. This is where you basically tell Snowflake, hey, I have an iceberg table. Here's the location of its current metadata, top level metadata JSON file. And then Snowflake reads that metadata, builds whatever Snowflake metadata it wants to internally, and then Snowflake can query that table in a read-only fashion. What Tabular does is sets it up so keeping that in sync is automated, so that any updates you make to Tabular automatically are reflected in Snowflake, including creating new tables, altering tables, dropping tables. We synchronize all those operations into the Snowflake catalog, so that it's always in sync with the Tabular catalog, and then it becomes read-only from the Snowflake side. On the plus side, I will say, because Tabular does such a great job at the intelligent optimization, what we find is that it's very common for Tabular managed Iceberg tables to outperform not just Snowflake managed Iceberg tables, but Snowflake native tables, especially for larger data sets. So we see that not only in Snowflake, we see that also in BigQuery, where we do a similar synchronization, that Tabular managed Iceberg tables are outperforming native formats in these engines, and that's like just really exciting to see for this whole architecture paradigm where we're separating compute and storage, and you can get really great performance generically by optimizing these Iceberg tables. Any benchmarking on the table optimizer or query performance, data storage cost savings? Yeah, so I mentioned it a little bit. Like generally, we see that we outperform native tables in a lot of cases. And thinking through what's the cost benefit analysis there. So obviously, one of the things that you pay for, if you're using the Tabular platform, if you want to, this is all optional. You can turn these things on and off on a per table basis. But if you choose to use our optimizing services, we charge for like amount of data we optimize, similar to file loader. So the more gigs we optimize for you, there's a cost. So what's the return on investment there for that cost? There's a couple pieces. The first one is how much do we reduce the storage size in your object store? So can we just reduce your storage bill? The answer to that is yes. By picking the right compression algorithms, we see even against Parquet, certainly for something like text, like JSON or CSV, when you turn it into Parquet and apply, the correct compression, you get 80-90%, storage reduction. Really, really big wins. But even against sort of native Parquet files, by hyper tuning the compression and the sorting and the clustering, all that matters in terms of reducing the size on disk. We'd see on average about a 40% size reduction on disk. 40%. So that's a meaningful number for reducing your storage cost. The other great thing about that is it directly also improves query performance and reduces, obviously your compute cost, because the more performant your queries are, the less expensive they are. Especially in these modern warehouses where you're paying on demand. So we again see if for read heavy queries, you can see up to a 40% reduction in query runtime. It really depends on the query patterns, but you can see very big wins on the query side as well, based on these storage optimizations that we're doing. And we see those across the engines, right? We're not hyper tuned just for Snowflake query engine. It also works great in Spark and Trino and BigQuery and everything else. And so in terms of full ROI, what we typically see for customers is if you keep your data on disk for a year, at least, then you are getting back more than you paid for that optimization. So if you paid $1 to Tabular to get it optimized, you'll save $3 over the course of a year having that data on S3, plus all the queries that go against it. Are there any limitations on the number of items in the catalog? There are some practical limitations that we've put in place. They're quite high. These are more kind of defensive, since it's a SaaS model and it's a multi-tenant architecture. There are some practical limits in the system, but we've got customers that have hundreds of thousands of tables in the catalog, and millions, maybe tens of millions of authorizations and sort of access control policy against those tables. So while there are practical limits, they're quite high, and even then, the system would, I think, support more than that if necessary. Last question here. If a customer with existing data lake in object stores wants to adopt Iceberg Tabular, do we create a duplicate copy of those files as part of creating performant Iceberg tables, or is it metadata only? And the answer is it can be both. What we would probably start with is migrating those tables in place and just doing the metadata operations. So, build the Iceberg metadata around whatever, Parquet files you might have in an object store and register that table with Tabular. That means you can start using Tabular and all the access controls right away, and that's great. For new data coming in, we might be optimizing that. And then what we're looking for is opportunities to say like, hey, if we went back and actually rewrote all the old data, would that be a win? Would that be a win because we're going to compress it 40% and you look like you keep your data for 3 years and you're actually going to save a whole bunch of money by going back and rewriting that old data, even though you may not query it in the future. And that's a case-by-case basis and something that our system provides recommendations on of like, hey, should you go back and rewrite old data? By default, we won't do it. We won't do it for new data. But there are times when it makes sense. So I guess the answer is both. We can migrate data in place, but sometimes it makes sense to rewrite it. Okay. Got through all the questions. Got through it in time. Maybe with the chance for everybody to take a bio break before they get to their next meeting. Any other final questions or Rick, anything before we sign off? Awesome. I hope y'all walked away with a better understanding of the Tabular platform and how we really make the best practice of Iceberg quite easy to implement.
There's one more question.
Oh, one more. Can we choose when to optimize data? When this data is most useful? That yeah, absolutely. So all of this is configurable in terms of when to optimize, how aggressively to optimize, whether it's on or off. There's a lot of knobs and levers that you can pull on to really tune how our system responds to new data coming in. For the most part, it does a really good job of that. Like again, it's looking at those query patterns, it's looking at read and write patterns, and it kind of knows like, hey, if no one's going to read this data, I'm not going to bother optimizing it. Things like that. All right. Thanks, everyone. Appreciate the time today. Go sign up for Tabular. Try it out. It's free.